Hello, I'm Alexander Bondarenko, and it is my pleasure to welcome you to the presentation of our work towards understanding and answering comparative questions. Our work is motivated by decision-making processes that are often accompanied by comparisons between several options. And these comparisons range from simple factual, like whether Messi or Ronaldo scored more goals in 2021, to life-changing and probably highly subjective, like is it better to move abroad or stay. The study results published in 2020 showed that when it comes to big decision, 80% of American adults prefer to do their own research online. Such that comparative questions are being asked in online forums or submitted as queries to search engine. Analyzing a search engine log in 2020, we found that at least 3% of searches were comparative questions, with half of them being non-factual. While result presentation for factual comparisons can be simple facts, like Messi accounted for 28 goals in all competitions in 2021, meanwhile Ronaldo amassed only 20. The search result for non-factual and subjective comparison could account for different manifestations like showing side-by-side opinions and arguments for or against the comparison option. But to be able to put this potential answer on the correct pro or con side, a respective stance of those answers should be identified. To do so, we created a data set with questions that we manually labeled as comparative or not. And on the token level, we labeled comparative questions with the tokens of interests like comparison objects, aspects, predicates. And for a subset of comparative questions, we extracted potential answers and annotated their respective stance. We built and evaluated classifiers to identify comparative questions and classify subjective comparative questions, and also to parse questions by identifying the objects, aspects, and predicates. And finally, we built a stance detector for potential answers to comparative questions. So on the next slide, there is an example of a comparative question from our dataset, which requests to compare a cat object versus a dog object over an aspect being friend, where the predicate better introduces an aspect into comparison. And a potential answer, cats can be quite affectionate and attentive and thus are good friends, should be classified as a pro first object. Our dataset contains more than 30,000 questions randomly sampled from publicly available datasets like MS Marco with 3,500 comparative in it, with a half of questions being subjective. For a subset of almost 1,000 comparative questions, we also extracted potential answers, text passages, and manually labeled them with 4 stance labels. Okay, our first classifier is a cascading ensemble that recalls 71% of comparative questions in our dataset at precision of 1. We run our experiments in a tenfold cross-validation settings, and at the first step we handcrafted lexicosyntactic rules to identify comparative questions, like, for example, if a question contains an adverb in a comparative form and a conjunction, or it should be classified as a comparative. After each step in our ensemble, we remove correctly identified comparative questions such that at the next step, more sophisticated classifier is trained and fine-tuned for more difficult cases. And starting from feature-based classifications, in our case, it was a logistic regression, we chose the operating points in terms of probability thresholds of the classifier such that we keep the classification at the precision of 1. So combining all the steps, rules, feature-based neural, and at the end averaging the classified decision probabilities, all in all, our ensemble recalls more than 70% of comparative questions. So here our data set contains different kinds of comparative questions. One of them are direct when the comparison objects like cat and dog are explicitly mentioned in questions. Indirect comparative questions where rather a group of possible comparison objects like what pet is the best friend only mentioned. Some questions have comparison aspects and the others not. And to parse the comparative questions, we selected as a baseline approach a WSDM architecture proposed by Aurora, who also extracted objects and aspects but in comparative sentences, and we fine-tuned the Roberta classifier, the token-based classifier on our dataset, with the results that predicates can be recognized at best and the aspect the worst performance shown, but we also propose several steps to improve the classification. And more details, for more details, I encourage you to look into our paper. So, and finally, for the stance detection, to remind, the task is given a comparative questions and comparison object and potential answer to classify whether the answer is pro first object, second, neutral, or there is no stance in the answer. We again experimented with several classifiers, including the transformer classifiers that we use to represent the questions, or we use them directly as the classifiers, where we extended the input with some sentiment prompts and also experimented with masking of comparison objects, and a few more details on the next slide. But first we started with identifying the subjective questions. It's actually those questions of interest for which the potential answer can convey any stance. And again, Roberta as a classifier showed to be the most effective one, with which we were able to achieve F1 score of 95%. So the most effective classification of approach was as follows. We masked comparison object as object 1 or object 2 in questions and in answer, to prompt the classifier to actually better learn the context of around the objects, but not the objects themselves. Then we extended the masked object with a sentiment prompt like is better, and then we constructed an input to Roberta as object, sentiment prompt as beta, separator, and then the answer. And the highest accuracy that we were able to achieve on 4 labels was 63%. Okay, to summarize, in our work we constructed a dataset that contains comparative questions labeled with comparison objects aspects, and also for a subset of comparative questions we labeled potential answers with their respective stance. We proposed and evaluated classifiers for comparative questions and also for parsing those questions, and we proposed a stance detector for potential answers. Well, there is still some work to do, like for example, plenty of room for improving the stance detection of comparative answers. And another interesting task is actually to build an automatic matching between comparison object and questions and answers in cases when, for example, abbreviation or synonyms are used. Thank you very much for your attention, and I'm especially grateful to Sigayar for providing me with a student author registration award that allows me to participate at the conference.